First, we are going to determine whether the following relation represents a function. And so you'll notice in this first example, they have given us a list of ordered pairs. Now, they are also asking us to give the domain and range for the relation. So let's start with, does the relation represent a function? And so in terms of what is a function, what you have to think about it is that every x value, which x is always the first coordinate in an ordered pair, has exactly one y value. And so when we look at a list of ordered pairs, what we're checking is to make sure that your x values are not repeated. Because if you had x values that were paired with more than one y value, then you are not satisfying the definition of a function. So your x values cannot be repeated. So I'm going to go through and check. So there's an x of 0. It only has one y value in that list of -6. Here is an x value of -2. It only has one y value, and that is +1. Here is an x value of 9. It only has one y value, which is 9. And then here is an x value of 1, and it only has one y value of 1. Now, notice it is okay that the y values got repeated. That is not part of the definition of a function. That's something we called one-to-one, which we'll talk about later. So it's the fact that your x values cannot be repeated. So when they ask me to list the values of the domain, I'm going to list them in set notation. And so my x's in this case are 0, -2, +9, and +1. And then when they ask me to list the values of my range, that refers to the y values. So again, domain is your x values, your range would be your y values. And so in this case, my y values are -6, +1, +9, and then +1 again. But we're not going to list it twice because we're only making a list of what x values, and just because it appears twice does not mean that we have to list it twice. Now, on the second type of problem, they, instead of giving us a list of ordered pairs, they could give us an equation. And when they're asking us to determine whether the equation defines y as a function of x, again, that's just a way of asking you, is this a function? Is y a function of x? So the first thing that you need to do is get the y by itself. So in this case, I would subtract x on both sides so that I can get y by itself. So I'd have y equal, and it doesn't really matter the order of these terms. I typically put my variable up front just because I'm thinking of an equation of a line. But you definitely, you're not multiplying there, so don't call it -24x. It's a -x, and then it's a +24. Now, you either have to be able to picture the graph, which in this case is a diagonal line with a negative slope going down, and once we graph lines, you'll know that more often. Or you've got to think to yourself, going back to the definition, does every x value have exactly one y? So you don't want to be able to plug in one x and get two different y's. And so I just think in terms of a table, just start plugging in some x's. If I were to plug in 0, well, there's no such thing as -0, but 0 plus 24 would be 24. So there's no way I could get more than one y value there. If I plugged in +1, you'd have, according to the equation, -1 plus the 24 would give you 23. So again, there's no way I'm going to get more than one y value there. And then let's say you plugged in -1. And so when I take -1, that becomes +1, plus 24 would be 25. So in each case, every x that I can think of is only going to produce one y value. So in this case, I would say yes in terms of y is a function of x. Now, let me talk about the next test, and then we can go back, and if you knew that the graph was a line, you can also determine from that, knowing the picture, why you could say that it was a function. So when they asked me to use something called the vertical line test to determine if y is a function of x, when you're using the vertical line test, you're going to draw lines through all parts of the graph, and I should say vertical lines, not any kind of line. We're going to draw vertical lines. And if you only cross one point on the graph each time, then we do say it is a function. So the key is you cannot cross more than 1 point. So when I look at this first example, which is a diagonal line, similar to my one from the second question, notice every time I draw a vertical line, I'm only crossing one place of the graph. So I would say in this case, yes, this is a function. Y is a function of x. And as you can see back up here, same thing happens. So if you were able to picture that was a linear function, you would have known from the vertical line test that y is a function of x. Now, when I come down to the circle, if I'm very careful and I draw my vertical line just right here, yes, I'm only crossing the edge of the circle, but it says I have to be able to do it through all parts of the graph. And so notice when I draw a vertical line right here, I'm crossing that graph at more than 1 point. So in that case, I would have to say no, that y is not a function. Okay, or y is not a function of x. So the key is you can only cross 1 point at every time. And if there's any place that you cross more than once, it is not a function. Now, one of the other things they could ask you to do from these pictures is they could ask you to state the domain and range. And so, remember, domain refers to your x's. And if I look at this particular line, if they don't have arrows, then I have to assume this graph is stopping right here. And so if I'm looking at the x's, 1, 2, 3, 4, 5, that x is starting at -5. Because there is an actual point there, I'm going to put a square bracket to say it touches at -5. Now, as I look all the way to the right, so with domain, you're going left to right, then notice that the line ends right here at an x value of 1, 2, 3, 4. And because it touches at 4, I use a square bracket. So my domain goes from x's that started at -5 and stopped at 4. Now with range, you have to look at the graph from bottom to top. So you're looking at it from bottom to top. So the first y value that gets touched right here, that is a y value of 0. And because it gets touched, it's a square bracket. And then my eyes have to go up. So bottom to top. And so notice this is the highest point on the graph. And if I look at that particular y value, I didn't put enough marks, so we'll just say 1, 2, 3, 4. We'll say it stops there at 5. Then it has a y value of 5, and because it touches, we put a square bracket. Now, if you had a graph that didn't touch because you saw an open circle, then you would simply put a parentheses. So, for example, let me come down here for just a minute. Let's say that this graph had an open circle at 1, and then it just continued like that. And so on the domain, So on the domain, you would say it starts at 1, but it's not touching. So you'd put a parenthesis like that. Now notice, because of the arrow, that just says it keeps going and going and going as you go to the right. So we actually call that infinity. And we never touch infinity, so you would put a parenthesis like that as well. And then on the range, again, because this graph keeps going and going and going, technically there's never a bottom, so we call that negative infinity. And then as you come up, we'll just put marks like that. The graph stops at 2, but because of the open circle, it doesn't touch it. Okay? And then again, on last but not least, on this circle, if I was giving the domain and range, notice that on my x's, the x's start at touching at -2, so that would be a square bracket. And then as I move to the right, they are stopping at +2, and because they touch, I put a square bracket. And then on my range, my y values down here are starting at 0 and touching, and then as I come up, 1, 2, 3, 4, they are stopping at 4.